Um, my name is Johannes Kornfeld. I'm from the distributor CODICO and product manager for ACCONEER, and would like to say welcome to our. My name is Johannes Kornfeld. I'm from the distributor CODICO and product manager for ACCONEER, and would like to say welcome to our webinar 2022 for the ACCONEER products. Just a few words. All of you will get the presentation and the answers to the questions you will please put through the chat afterwards. We will mail it to you, to all the people who participated, and yeah, enjoy. And would like to hand over to Magnus, who will do a short introduction round before we start.
Okay, thank you very much. So, hello everyone. Very nice to see you. I'm Magnus Garvard, heading up sales and business development at ACCONEER. So I have a small team with me today here. So please.
Yes. So good morning, everyone. My name is Martin Hoff. I work as a customer project manager here at ACCONEER.
And my name is Anna Alrid, and I head up the marketing and communications function at ACCONEER.
Okay, so today we will show you a presentation about our product, and we will talk a little bit about the roadmap and the use cases, and we will also show you some examples of customer products on the market. So let me share the screen. You can see it? Yep. Okay. All right. So what we do at ACCONEER is pulse coherent radar working in the 60 gigahertz domain. So as you can see here in the picture, it's a very small chip which contains a complete radar system with integrated antennas, analog part and digital part in one chip. It's a BGA package. So it's very small. 5 times 5 millimeter, 0.8 millimeter high. I think it's the smallest radar we have seen in the market. But still, the very unique thing is the way we perform radar technology, and we call it pulse coherent radar technology. And what it is that we are sending out very short picosecond pulses, and between sending out and receiving those pulses, we are shutting down the sender and the receiver. By that, we can maintain a very low power system. And this radar has been in the market for around 4 years, fully qualified. We have the production completely set up with wafers produced by global foundries in Singapore, and the package is done by Amkor in Korea. And to this date, we have shipped more than 800,000 of these chips. And we are in a very interesting phase where we are ramping up in different markets. So these are the main segments that we are working with. And today, most of the products, our customers' products on the market, are within Internet of Things. Also, when it comes to customers of CODICO, this is where we see the biggest volumes at the moment. And use cases like detecting cars in parking lots, detecting level in different tanks, people presence detection, etc. So when it comes to parking, for example, we see that we have basically 100% of the parking sensors outdoors, and we're now also moving into indoor parking. One of the reasons we have many products in this segment is, of course, that it's a very good fit with the product, low power consumption, and it's robust for outdoor usage. But also the fact that it's pretty short lead times in this market. Automotive, it's will probably end up as being our biggest segment when it comes to volumes. Here we're not really a car radar, so we're operating in the 60 gigahertz domain, and 70 gigahertz is stipulated for detecting other cars for ADAS system and so on. But there are many use cases for 60 gigahertz, for example, inside the cabin to detect people inside the cabin, or user-related use cases like opening the trunk lid, etc. And here we're working very tight with the tier one called Alps Alpine. We have design wins with major car manufacturers. So we hope to see cars rolling out during this year. As mentioned, it takes a little bit of time until cars are in the market. Consumer electronics, interesting use cases like also people presence detection to wake up devices, gesture control to control devices, etc. We'll show you some example of people presence here later on. Industrial applications, quite much related to IoT, distance measurements, robotics, vibrations measurements, etc. When it comes to the benefits of the product, the unique thing with ACCONEER is the combination of low power consumption and maintaining a high performance, high accurate radar system. So when it comes to the accuracy, we can measure absolute distance to objects down to millimeter precision, so plus minus 1 millimeter. So that's the absolute distance from the sensor to an object. We can also look into the phase domain and see relative movements down to micrometers, so around 20 to 40 micrometers, so very tiny, small movements back and forth. So this is used, for example, for a vital sign, breathing, heart rate detection, but also industrial application. At the same time, and having this high performance, we have very low power consumption. So, and the power consumption, of course, depends on the update rate, how often you measure. But running 10 hertz, we're below a milliwatt for the sensor itself. So we're in the microwatt domain, which is of course, very attractive for any battery-driven devices, etc. So these are the unique thing with the pulsed coherent radar technology. And then, of course, we can track movements, we can set the update rate, runtime, we can detect gestures, optimized integration. By that we mean that we have a very small, neat solution. Also the fact that you can put the sensor completely behind plastic and hide the sensor for a nice design and also robust design. So the 60 gigahertz signal bounce on most things around you. It bounces 100% on metal, close to 100% on water. Plastic and wood are semi-transparent, so we can see plastic objects if they are in front of the sensor. But when you have a plastic cover close to the sensor and preferably parallel to the sensor, you get very small attenuation, and even if you have a little bit of thicker plastic, it works fine. Material identification, that is something we can classify different surfaces if we have possibility to collect data. So, for example, we have robot lawn mowers where we can collect data and see if the lawn mower is still on grass or running outside the grass. Or we have vacuum cleaners where we can collect data with machine learning and see if the vacuum cleaner is running on carpet or on hard floor. So it's not that you can just run it through out in a room and see different materials, but if you have the possibility to go over materials, collect data, and build a profile with machine learning, you can start characterize different materials. Then we come to robustness, and this is, of course, comes with the radar technology as such. So very often, because we have a unique radar that is small, cost efficient, and not power hungry, we often get compared with other sensor technologies like infrared, ultrasonic, etc. And here, the radar is very robust. It is independent of light condition. It works in different temperatures, independent of sounds. You can detect objects with different colors, etc. So outdoor usage is good. Of course, works indoors as well. But the robust detection and the high performance you get with the radar as such. Looking at the radar market and in particular 60 gigahertz domain. So of course, with this high frequency, 60 gigahertz, you can design very small, nice solutions with small antennas. And you also get very high resolution and performance and accuracy. We see a lot of the bigger companies moving into this domain, like Texas Instruments, Infineon. We have Kaiku Tech from Korea, Social Next Japan, some players from China, etc. All of our competitors are using continuous wave frequency modulated radars. So per definition, they are sending all the time. And ACCONEER is the only radar with a pulsed technology. So that means that we can always have lower power consumption. Then we also made design choices to make it very small, and by that also cost efficient. So this is how we are position ourselves among the competition. So you can find other radars that have reached longer range, have more senders, more receivers, but then you are in a different size, different price, of course, higher cost, and also much higher power consumption. And as you can see here to the left, we have the 111 is the product we have on the market today. There will be an upgraded version 1-to-1 later on during this year. We'll have the same kind of design and size and antenna. And then we are now also designing the next generation A2, which will be slightly bigger, still pulse coherent, but then using multiple senders and receivers. So you get even more advanced and rich data with angular resolution as well. So the A2 is planned for 2024. Some technical background. The radiation pattern is pretty wide from the sensor, so it's 80 degrees in one direction and 40 in the other. And this is the half power beam width, so it means that this is where we have most of the power, most of the energy. You can detect some objects outside of this cone, but this is mainly corresponds to the field of view. And we have one sender, one receiver, so it means that we can see multiple objects that have different distance to the sensor. If you have one object moving along the radius with the same distance to the sensor, it will look the same. So we don't have angle resolution of an object moving kind of with an angle from the sensor. To pinpoint the angle, you need to work with multiple sensors, and then you can triangulate and detect where the object is. The radiation pattern is fixed from a software perspective, so you cannot really change that in parameters. But with the physical integration, you can change this. So if, for example, if you use the electrical lenses, you can narrow down the beam. We have with the evaluation kit, we have example lenses narrowing down to 10 degrees, and then you also get more power straight forward, so you can reach longer range. So as mentioned, the sensor is a complete radar system with antennas integrated, analog part and digital part. Then we have raw data output to SPI. It needs a host processor to take care of this pulsed raw data. And at ACCONEER, we provide the radar software, which is a free license, and you can download the software from our webpage. Typically, a processor you need is a Cortex. You can have a Cortex M0, M4, or if you already have a processor in your system, you can use that. SPI 4-wire SPI interface. You need a power supply, 1.8 voltage. You need a clock reference, and many customers are buying the sensor and integrate this from a hardware perspective. We also provide already integrated modules with a host processor, and I will give you some examples later on here. Looking at the software, we have implemented this in C code and ported this to different cores like Raspberry Pi, ARM-based Cortex, etc. And we have an SDK with APIs. So there are low-level APIs where you get the radar data stream. Envelope gives you filtered radar data, which basically gives you the amplitude as a function of a distance. So this is good for detecting static objects. And then we have IQ service, which provide the full radar data, also with the IQ information and the information in the phase domain for more advanced use cases. So these are the low-level APIs to get the radar data stream itself. We also have detectors, which are high-level APIs and for specific use cases, for example, for presence detection. And here you will basically, you can set as input parameter, you can set the range from your region of interest, and then you will get a notification if something is moving, if you have a people presence within that range. We have a distance measurement detector, and we have obstacle detection for robotic use cases. So this is the product lineup. You see the sensor itself, 111 to the left. So it's the same sensor then in different modules and evaluation kits. So we have 4 different modules, which are sensor integrated with a host MCU. The 112 has a Cortex M7 on the backside. XM122 is a Cortex M4 from Nordic that also includes the Bluetooth. So you see the Bluetooth antenna on top. And to the right, you see the 132, which includes, there you see the components on one side, and you have a Cortex M0 from ST. We also have a specific version of that, 131, dedicated for presence detection, even smaller and really cost efficient. So the 132 is basically you can get in high volumes below $10, and the 31 is 20% cheaper at $8 in high volumes. So the 132 and 131 are the modules that we are selling in higher volumes, and it's fairly easy to integrate to your system. They have solder plates, you can solder to your PCB, and you get all the components pre-integrated. For the modules, we also have breakout cards. For example, you see there with the 112, we have the XB112. And there you can access the module with over USB. You can connect the module to your PC. And we have Python tools called Exploration Tool, where you can see real-time radar data in Python. You can set all the parameters we then have in our SDK. You can try out your use case. We have example algorithms for presence, for breathing, etc., for parking detection, and so on. So it's been a very good tool for our customers to quickly get up and running, see the radar data, and to evaluate your different use cases. And also here you can see the lens kit, which is then adapted with a holder for different breakout cards, and we have 2 example lenses, one spherical and one freshness zone plate. And they have similar performance. They narrow down the beam to 10 degrees, and then you can also have more power straight forward and get longer range. So just a few words about the two modules, 132 and 131. So these are designed to be very cost efficient. As mentioned, it's a Cortex M0 for the host processor. The 132 basically supports all the use cases we have, and it's used for parking detection, level measurements, etc. The 131 we have stripped down even further. It's even smaller, and we have dedicated this for presence and motion detection. So you can only run these kind of applications on top of the 131. But then on the other hand, it's even lower price and even smaller. Going into use cases. So as mentioned, we're working with these four main markets. So starting with consumer devices, and here we have everything from robotics to electronics like PCs, laptops, and headphones, etc. These are some of the customers we have that have launched in the market. You see 3 different robots here from Japan. Jukai has provided a robot where you can kind of interact. It detects a presence when you're getting close. It kind of wakes up, and you can start to interact with this robot. Lavot to the upper right is companion robot. The sensor, our sensor, is in the front, behind the clothes and behind the plastics, and it's used for obstacle detection. So this robot is moving, and then basically the radar detects so you don't run into things. One important thing here has been that we can detect the glass, for example, which is not possible with infrared, so you don't run into any glass objects. We have Poik from Sony, also in Japan, and this is also a moving robot, mainly running on your table or your desk, and the radar is also here that used for obstacle detection. Then down to the left we have a CODICO customer in Italy. They have provided a lawnmower, and it's quite interesting. They are using multiple sensors. They are using it for obstacle detection, but also they have one sensor pointing down to the ground, and they have built with machine learning. They have built the functionality so the robot detects if you're still on grass or if you're outside the grass, and by that they can remove this cable that you need in standard lawnmowers today. So basically changing the game for lawn movers and really taking advantage of the rich data you get from the radar. Other examples in this segment is of course presence detection. Here we have sports equipment where you can see that you are running on this belt. You can also see the distance from the sensor to the person to see, how you are positioned. It can also be used for safety reasons to make sure you don't have any pets or kids getting close to the belt. And the sensor is then extremely sensitive even if you are standing still or getting close to this belt and don't get stuck behind the belt. So yeah, show you the first demo here. So Mark.
Okay.
Sorry. Maybe I should turn off the.
Okay. So this is this keyboard is integrating a radar sensor in front of the keyboard, so it's placed behind the plastic here in front, and it runs our presence detector. So if someone is sitting in front of the keyboard, the radar will pick up on the breathing, on the movements. And if I then walk away from the keyboard, I don't know if you can see my screen. Let's just do like that. The radar will sense that there is no one in front of the keyboard, and then it will send a signal to the PC to go into sleep or hibernate. And this keyboard can be configured to 1 minute, 10 minutes, or 20 minutes. So if you sort of go away from the keyboard, there is a configurable time for how long the computer will be sort of in the on mode.
And of course, there are also other sensors providing presence detection. But the good thing with the radar here is number one is that it's extremely, now you can see it's shutting down.
Yeah, it's shutting down.
It's extremely sensitive, so that means that even if you are completely still or sleeping, the radar detects the motion.
Exactly.
So that's one important thing. And another thing is, of course, that you also get the distance to the person. That can be used in different use cases to see if you are moving away or getting closer.
Yeah.
And I think the third one is that it's very small and need to put it behind the plastic, and it's invisible, and you can have a knife.
Yeah, there are no openings in front of or in the plastic of the keyboard here, so it's completely hidden behind the plastic. And this particular implementation of the presence is that you have to actually tap the button on the keyboard to wake up the PC, just to avoid that anyone going past the keyboard not waking up the system again. So that's one of the presence detection.
And for presence, you can expect up to 5 meter presence detection for detecting people walking into the room, for example. And we also have some partners that have been using multiple sensors to see if counting people if you're walking into a room or walking out from a room. Then you can see if this room is crowded or occupied, etc. All right. Thank you, Martin. We walk into the next segment. So IoT and smart cities. So this is a quite interesting segment, and we have a lot of different applications and use cases. So you see in this slide we have some examples of use cases that we are working on with customers, and the ones that are marked with green here is where we have launched products, and you can find our customers' products on the market. So within traffic, short range pedestrian and bikers flow. So as I mentioned, we go up to around 5 meter with the lens possibly a little bit longer, but then you get a more narrow beam to detect pedestrians, and you can use that, for example, to light up the traffic lights, etc. Touchless button. We have multiple customers using that for, instead of pushing a physical button, they use the radar sensor to have a touchless button when crossing a road, a crosswalk. So that's used outdoor for crosswalks, but also you see in smart buildings used inside buildings as well. We have customers that have launched solutions for bathrooms, and it's about toilets that are kind of flush control to have detecting people using it and getting close. We also have customers that are kind of detecting if you have people in the bathroom, and also if people are laying down on the floor. So with the presence detector, you also get the distance, so you can see if people are standing or sitting or lying on the floor. We have customers that integrated the sensor in lamps to detect people and light up rooms. ATMs within smart buildings, kind of, if you have a smaller room with an ATM, you can see if people are there, to avoid that people are kind of staying there or sleeping in that room. People counting, I mentioned that. See if people are walking in and out from a building or meeting room, etc. Then we have infrastructure. We have distance detection, so customer looking into train tracks, basically putting the sensor beside the track and then see if the track is moving. So today you have to manually monitor and check the tracks, but if you place a number of these sensors along the track, you can see if the track is moving and you need to do maintenance. Level measurements, many different kinds of tanks, smaller, bigger tanks, different kind of liquids, of course. Also related to waste management, where you can detect the level in waste bins. And we fairly recently also found the sewage market, where today people are using quite expensive and smaller number of very expensive sensors to detect the level and flows in sewer systems. With our sensor, you can have a very cost-efficient sensor, and you can place a number of them and get better visibility of the complete system. The main use case is to detect the level, but we also now, and we're doing some research that looks really promising to detect the surface velocity. So by looking at the ripple of the surface, we can detect the velocity of the water surface. Parking is a big market. We have parking detection, normally battery-driven devices outdoor to detect if a car is parked or not. That also relates to EV charging, where we have customers that would like to detect if a car is parked without charging at a public charging station. So these are some of our customers within parking, IoT solution in Europe, and Hancom in Korea, NHR, Taiwan. We have YNext in China. Also, as mentioned, vehicle detection for EV charging stations. So, and they can be located on the side of the car, but also in front of the car, of course. We also see some of these customers would like to detect, would like to have people detection to light up the display when you're getting close to the charging station. Example of customers for level detection, Packwise in Germany, looking into IBC tanks. Tel China, NHR, working with sewer level measurements. Martin, it's demo.
It's a demo time again, yeah. So let's see if we can see this. So this is a level sensor from a Finnish customer, and it is used to detect the distance or level in silos, for instance. It can be grain or it can be water of some sort. And this particular product is battery driven. It contains an LTE modem, so you can communicate with the backend system. It also contains a temperature sensor, and there is a gyro, so you can sense the orientation of this device. And then there is a very neat backend system where you can sort of access the sensor and set configuration to it to measure different distances, for instance. So let's see. I can just share my screen so you can see what it looks like. It's connected to the meeting. Okay, so here we are. So let me know when you can see it.
I think you will, yeah, you will see that.
Yeah, all right. Thank you. Okay, so this is the user interface on the backend side of the system. So here we can see the distance that the sensor is measuring, and it's been stationary on my desk for the night, so that's why the distance hasn't moved. So has been measuring the level to the ceiling of the house, and then this morning I picked it up and placed it against the wall, so that's why the distance has dropped to 0.5 meter. And now it's again pointing it towards the ceiling, so it's still on 2.5 meter. I have an indication of the quality of the signal, the amplitude. You can see the ambient temperature of the device and also the orientation. Here you can see that it was put flat on the table, and then I moved it, and then now it's flat again on the table, and a little bit of battery status. So this is a very neat little device, and I think that the battery time or battery life for this particular unit is like 5 years if you measure. I think it's once per hour or something like that.
Yep. And it's a Finnish company called iProtoxy.
Yep.
Doing this, and they are using this with their customers in waste level measurements in Finland, and also some liquid level use cases at the moment. Okay, back to the presentation. So the next segment here is industrial, and here we have and agriculture actually. So we have interesting use cases both within automation and also agriculture market. So a little bit about automation. So what we found here with our customers is that today people are using different kind of magnetic, capacitive, inductive sensors in production and automation. I mean, they are extremely short range, but with a radar, you can extend that range and you have more flexibility, and you can avoid that objects are kind of getting too close to the sensor and basically halting and interrupting the production process. Also, another important thing with the radar is that it's very kind of, it can detect a wide range of different materials. So we have customers working in the car manufacturing market, for example, to detect when cars and objects are getting to a station within the factory. And we have customers looking into other types of production and automation where they would like to detect objects on the belt getting to the station or the position of the object. So as mentioned, I mean, specifically maybe for the car industry, it's moving from using a lot of metal to new materials and using basically carbon. And here the radar has a big benefit of both detecting, of course, the metal, but also detecting carbon with high precision. And I can also mention, I mean, agriculture is also part of this segment, and here we have use cases like farming machinery to detect the height of a farming seeding machinery from the height from the machine to the ground, and we have, of course, level detection in different silos, etc. One example of an industrial sensor is banner.
Yeah.
Show that one.
I'll show that one. Yes. So this is an industrial proximity sensor, as Magnus said. So this particular sensor is configured so that it has 2 different detection zones. and it will output a binary signal if there is something in zone 1 or zone 2, and it will also turn on the LEDs when there is things in front of the sensor, and you can see that hopefully that the yellow LED indicates that it is in the closed zone. Then you move it away, then it will fully detect when I'm in the other zone. So there are 2 zones for this particular sensor, and it can be used, as Magnus said, for detecting when there are materials on a belt, for instance, and that they're placed in the correct position between those 2 detection zones. And those zones are, in this case, they are configurable in software. So you download it to this sensor, and then it will run autonomously and sort of report the results back on this industrial bus.
Yeah. And of course, the good thing there with the radar is that it can work in very harsh environment. It could be a lot of dust and dirt and so on.
Yeah.
Very good. And the last segment here is automotive, and here we're working very close with Alps Alpine. Use cases are mainly inside the cabin to monitor if people are there, to detect if you forget your kids or pets, for example, in the car. And we have use cases like opening the trunk lid with the foot, kind of gesture control as well. All right, so these were basically what we would like to show today. The CODICO can provide all the different products we have, the chip itself, the evaluation kits, and the modules. We have a developer page where you find software for both for the embedded and also for the evaluation kits, and Python code to look into the radar data with your PC. And it should be really easy to set up. So yeah, within 20 minutes, when you get hold of the evaluation kit, you should be able to start experiment and work with our evaluation kit. All right, so thank you very much.
Thank you. We got some questions, I think, so we can answer one or the other.
Yep.
Yes, so we will select a few of the questions that you have submitted in the chat, and then the rest of them will send out answers to afterwards. So let's start with the first one here. When using multiple sensors, is there a mechanism to avoid that the sensors interfere with each other?
So using, basically when you use multiple sensors, you can merge the data in the application domain. So they are not running in sync, they are running as independent system, but then you can use that, for example, for detecting people walking in and out from a room. Interference has basically not been a problem because we are just sending out very short pulses, and the likelihood of kind of interfere there is extremely small, and if they do that, they will kind of drift off quite fast. So we haven't seen that problem basically.
No. And if you have multiple sensors connected to the same host MCU, then of course you select with SPI bus which sensor to send and receive from, and then you do that in sequence.
Great, thank you. Could you break down into more detail what kind of data is in an output frame from a radar chip?
Yeah, I mean, basically, if you take for instance, the envelope service, which is probably the easiest one to sort of get a grasp on, you get, for each sweep, you get an amplitude value, and you get the distance to that amplitude. And if you are sort of looking into the more complex services, you will have more complex data, such as angular phase, sort of the phase of the received pulse as well. but if you are sort of interested in the theory and more of the details into that, we have a fantastic read the docs page with all of our services and detectors available and the theory behind that. So if you go to, or if you basically you Google read the docs ACCONEER, and then you will end up on the page where we have all of that information. And of course, the exact details of each service is described in our API documentation, so you can find it there.
We may add a link to that document in the.
Yeah,
For sure. Great. Here's another question. Is it possible to detect dirt and liquid on the floor? And if yes, what is a genuine distance?
Yeah, it should be possible to do that. We have done experiments in the past with that, but I cannot say exactly what the genuine distance or the distance you need from the sensor to water or dirt on the floor would be. Guess it depends a little bit on the mechanical integration of the sensor in the product and how far away from the device you need to detect those materials.
So it should probably be like 5 or 6 centimeters at least.
At least 5 or 6, yeah, at least 6 centimeters, I would say. And most likely will involve some sort of machine learning model to detect that. So.
Right. Is it possible to use one with the ESP microprocessor?
Yeah, it is. We have an SDK for ESP32 that's available.
Great.
I guess it's not on our webpage.
It's not on our webpage, so you need to sort of ask for it. It's not in our sort of official releases on the.
So either if you reach out to your CODICO representative or if you place a ticket on our webpage, we will be able to provide that.
Yes. And here's maybe a little bit of a tricky one, but is it possible to detect the velocity of a fluid in a full pipe? So there's no surface.
Yeah, that's interesting. I don't think we have done any experiments on that. I guess it would depend on the type of fluid that you have in the pipe, if we can get some sort of reflection back to the radar. But it sounds.
We actually have a customer that is looking into flow of seed in the pipe for farming machinery.
Yeah.
So they started with just looking into if there were any flow or not, but they have actually managed to get some data where you can start see the velocity as well.
Yeah, but then you have individual seeds coming through the pipe.
Exactly.
If you have a pipe that is sort of full with material, then I guess it will be.
Though then it will be very hard. Yeah. You need to have you need to be able to see some particles.
Some movement of some sort is probably needed.
Yeah, and here's another one related to liquids. Is it possible to measure distance within liquids, for example, water or oil?
We have tried that, or at least we have had customers who have tried to sort of measure if there is oil mixed with water and how much oil there is on top of water. But it's been proven to be quite difficult to get that to work.
For example, diesel, it's kind of semi-transparent, right?
Yeah.
So you can get one bounce on the diesel surface, and then you will have one bounce on the water further down. So it is possible, but it will take some.
It depends on the
algorithm development.
Yeah, it depends on the liquids, I would say.
Yes. What unit is the amplitude level given in?
It is not given in any unit. It's just the value from the AD converter that we get. So it hasn't got any unit.
Great. I think those were the questions that are more straightforward to answer. The rest of them we will address in a text format afterwards. But thank you very much for submitting so many interesting questions.
Thank you. As mentioned, we will send out the presentation material afterwards and also some document with all the answers to your questions. Yeah, feel free to place already some questions to us. You have the email contacts anyway. So yeah, thank you to the ACCONEER team for presenting and looking forward for nice new technical invitations with your sensors.
Absolutely. Thank you very much for joining.
Thank you.
Have a nice day.
Okay, have a good day.
Thank
Bye.
you.
Bye.
Bye.